Welcome to Creative World. In this video, we will solve Chapter 2 exercise problem number 2.83. While solving this problem, we will be using Kirchoff's current law. According to this law, a cumulative current on a node inside an electrical network is always equal to 0. Sum of all entering currents on a node is always equal to sum of all leaving currents from that node. We also will be using Ohm's law. According to this law, voltage across any resistance R is always equal to the product of current through it and the value of resistance itself. Now move towards the problem. Exercise problem number 2.83. Current I0 in given below figure is 2 mA. Then find voltage Vs. This is the circuit diagram of given problem. Inside this network, we have to find total supplied voltage of this voltage source labeled as Vs. So without wasting time, let's proceed towards the solution. In this network, the only information that is provided is the resistances of all branches and current through this resistive branch. So we will use this information to calculate voltage Vs. If we observe, there are two quantities given related to this 3 kilo ohm resistance. One is the resistance of this branch and other one is current through this branch. So using Ohm's law, we can calculate voltage across this resistance. And because of parallel connection, same voltage will be appearing across this 12 kilo ohm as well as 6 kilo ohm resistance. After knowing the voltage across these two resistances, we will be able to calculate their currents. And whenever the current through these branches will be calculated, sum of all these three currents will be equal to total supplied current through this branch. After calculating current through this branch, we will be able to calculate voltage across this 1 kilo ohm resistance. Voltage across this 12 kilo ohm resistance will be already calculated, so we will apply KVL in outer loop to calculate voltage Vs. So start solving the problem from this 3 kilo ohm resistance. Voltage across 3 kilo ohm resistance will be equal to the product of I0 and 3 kilo ohm. I0 is 2 mA. So voltage across this resistance will be 6 volt. Milli will cancel out with K and product of 2 and 3 will 6 volt. Now this 6 volt is also appearing across 12 kilo ohm and 6 kilo ohm as well because of parallel connection. We can calculate current of 12 kilo ohm as well as 6 kilo ohm. Before calculating the currents of these two resistances, we have to label these branch currents. This branch current will be labeled as I1 and this branch current will be labeled as I2. Value of I1 will be 6 volt divided by the value of resistance, that is 6 kilo ohm. 6 volt divided by 6 kilo ohm will result 1 milliampere. Similarly, current I2 will be equal to 6 volt divided by 12 kilo ohm. So the value of I2 will be 0.5 milliampere. We have calculated the values of current through all these three branches, so modify the network by indicating the values of currents along with their directions in this network. Directions of current through these branches will be downward because only one current is entering on this node and it is leaving through these three branches. Current of this branch will be considered as total current and it will be equal to the sum of all these three leaving currents, 1 milliampere plus 2 milliampere plus 0.5 milliampere. So the total current will be equal to 3.5 milliampere. We have calculated this total supplied current, so we can calculate voltage across this 1 kilo ohm resistance as well. So voltage across this resistance will be equal to the product of current through it and the value of resistance itself. 3.5 milliampere multiplied by 1 kilo ohm. So the product of 3.5 milli and 1K will be 3.5 volt only. Milli will cancel out with K. Now we have calculated voltage across this 1 kilo ohm resistance. Voltage across this 12 kilo ohm resistance is previously calculated, that is 6 volt. So modify the circuit by indicating the voltage across these two resistances with their polarities. Voltage polarities across these resistances is taken according to passive sign convention theory. In the light of this theory, current entering terminal is taken with positive sign and current leaving terminals are taken with negative sign. Direction of current through this branch will be clockwise direction because this only current is coming on this node and distributing among these three branches. Now, in order to calculate total supplied voltage, we will apply Kirchoff's voltage law in this outer loop. For that purpose, we have to assume the direction of current inside this loop. I am assuming the direction of current clockwise. You may take counterclockwise as well. Now write KVL equation for this outer loop. Start from here. Current entering terminal is positive, so 6 volt will be taken with positive sign. Next, voltage source current entering terminal is negative, so Vs will be taken with negative sign. And next is 1 kilo ohm resistance, current entering terminal is positive, so 3.5 volt will be taken with positive sign. Now add 3.5 volt and 6 volt together, it will result 9.5 volt. And place this minus Vs on the other hand side of equal to calculate its value, that will be 9.5 volt only. So the value of Vs inside this network is 9.5 volt. This was exercise problem number 2.83. Thank you. See you again in next video.